All right, welcome to the video for chemical reactions, chapter 2, section 4. So we start to get into some of the more interesting parts of chemistry, in my opinion. All right, so before we talk about chemical reactions, we have to talk about chemical changes, right? We talked about physical changes already, which are things like ripping, tearing apart, breaking down. Chemical changes, though, are very different, and they're based on changing a chemical property. And chemical properties of substances are the ability of that substance to undergo a chemical change. So chemical changes and chemical properties are very closely related. Now, during a chemical change, the actual composition of the matter always changes. Once again, that's very, very different from a physical change. In a physical change, like if you cut down a tree and use the chainsaw, cut up into pieces, the pieces are all still wood, still part of the tree. If you were to burn that, then that would be a chemical change, and what you're left with is very different than what you started with. All right. So a very common example is hydrogen and oxygen making water, right? Where the composition of the matter changes. Water is very different than hydrogen, and it's very different than oxygen. Okay, so the chemical reaction is what actually happens during this chemical change. Okay, and a common example that you'll probably see me use a whole lot in class this year, right, is going to be hydrogen plus oxygen yielding or making water. And then I'll finish in the rest of the formula. When you learn to balance equations, you're all going to become experts at this. So the actual chemical equation is 2 hydrogen molecules plus 1 oxygen molecule is going to make 2 water molecules. Now, the parts here over on the left are called reactants. They're the substances at the start of the reaction. In this case, the hydrogen and the oxygen are the reactants. Okay? And the products, in this case, there's one product. It's the substances at the end of the reaction, which in this case is water. Okay, so how do you recognize chemical changes that distinguishes them from physical changes? Well, some possible clues might include a transfer of energy, right? Usually heat. So if it's heating up or it's cooling down, then that's a possibility of a chemical change. There might be a color change. A gas production. If you see a lot of gas bubbles bubbling out, that's usually indicative of a chemical change. You can have a precipitate formation. Remember the demonstration I did in class where I poured a clear liquid from a flask into a clear liquid in a beaker, and we got that bright yellow-orange color. Right? There was a precipitate, which was the lead iodide. Now, you have to remember that these are just clues. There can be a change in temperature in the case of just a physical change. So to really know that a chemical change took place, you would actually need to test the products and reactants to make sure that they're different. Now, another key thing to remember in chemical reactions, and the reason why a slide or so ago I drew the twos in front of things, was the law of conservation of mass. And that states that in any chemical reaction, or physical change for that matter, in this case chemical reaction, mass is conserved. Now what that means is the mass of the products is going to be equal to the mass of reactants. The number of atoms on the left have to be equal to the number of atoms on the right. So if I say 2H2 plus O2 yields 2H2O. There's 2H2, so there's 4 hydrogens, 2 H2s, 4 hydrogens, 2 oxygens, 2 oxygens. The number of the products equals the number of the reactants, and the mass of the products equals the mass of the reactants. So mass is neither created or destroyed. We combined them to make a new substance, but we didn't create or destroy anything. All right, so there's some keywords that usually imply a chemical reaction took place. Things like burn. Whenever you're burning something, it's a chemical reaction. When something rots, chemical. Rust is actually a reaction between the metal on the surface and oxygen in the atmosphere. When something decomposes, breaks down into something smaller. Fermentation, when yeast digest sugar and make alcohol and carbon dioxide. That's a chemical reaction. When something explodes, really that's just a very, very rapid burning. Or when something corrodes, which is very similar to rust. Right? So these are some key terms. Once again, they imply a chemical reaction has taken place. But to really prove it, you would have to test both the reactants and the products. All right, that brings us to the end of this video. See you soon.